Hello, math friends. Welcome back to A Squared Math and Stuff. This example here, we are still focusing on calculating the area of regular polygons. In this example, though, we are only given a side length. So what I want you to think about is it looks like we're not given a whole lot of information, but start thinking back to the other two examples that we did. The other two examples we created triangles from the center of our polygon. And with those triangles, we were able to figure out a bunch of different information. So it doesn't look like a whole lot right now, but when we start to think about all of these triangles that make up this heptagon, because we have a seven-sided figure here, we can actually calculate the central angle. So recall that our central angle is 360 degrees divided by the number of sides. So let me write that for you again. Central angle is equal to 360 degrees divided by n, or the number of sides. N-U-M, -ber. Okay, so in this case we have 7 sides. So our central angle is equal to 360 degrees divided by 7. Now that, my friends, is not a fun number to work with. We're talking 51.429 degrees, and I rounded that to the third decimal place. And I did that because we want to round our final answer to 2 decimal places, so I'm working with the third one here. Now we know the 51.429 degrees, and that goes right here, 51.429 degrees. And we also know that we can drop a height of any triangle. So dropping the height of this triangle, we create a right angle, which creates a right triangle. And once we have a right triangle, we can work with our trig ratios, our sine, our cosine, and our tangent. So I'm going to take this triangle that I have up here and redraw it. Let's draw it here. We have our 5.6 feet, and we had this angle of 51.429 degrees. And then I'm telling you to drop the height. Dropping the height, we get this, we get a 90-degree angle. With this, we have created a perpendicular bisector, which means these two sections are congruent. That also means that this angle and this angle are congruent. And we know that because this is a regular polygon, which means that this length and this length are exactly the same. So it's an isosceles triangle. And when you drop a height in an isosceles triangle, you have an angle bisector and a perpendicular bisector for the side length opposite of that angle. What I'm going to do now is I'm only going to focus on the left-hand side of this triangle here. So let's redraw just our right triangle, because then we can start seeing things a little more clear here. Dropping that height allowed us to split the 5.6 in half. So if I take 5.6 and I divide that by 2, I get 2.8. So we're actually looking at 2.8 feet for our base. We aren't able to figure out the height. The height is still an unknown factor to us. This here is the radius, or the hypotenuse, of this right triangle. It's the radius of our polygon, the hypotenuse of the right triangle. And we know that angle, we have the angle of 51.429 degrees. Wonderful number. We're going to make it even more fun to work with, and we're going to divide that in 2. So take 51.429, cut that in half, and we get what? 25.7 25.715 degrees. So this angle here, we're talking 25.715 degrees. Now that we have this angle, and we have an opposite side of that angle, we can work with our trig ratios. The height here is the adjacent side to this 25.715 degree angle. And then we have our hypotenuse. Recall that the area formula for a triangle is 1/2 base times height. We have our base, but we need to calculate the height. So we don't really need to worry about the radius or the hypotenuse at all. So let's focus on calculating the height, not the base. The base we were given. Let's calculate this height. 2.8 feet, we know, that's the opposite side length. Height, we're looking for, that's the adjacent side length. So we are looking for the trig ratio that relates the opposite and adjacent sides. And the trig ratio that relates those two is our tangent ratio. So let's work with the tangent ratio. So tangent of 25.715 degrees is equal to the opposite side, which is 2.8, divided by the adjacent side, which is our height. I'm going to put this over 1 so I can do some cross multiplication. And then so we end up with the height times tangent of 25.715 degrees is equal to 2.8. We still need to get the height by itself, so it's being multiplied by tangent. Let's divide that tangent out. Dividing out tangent 25.715 degrees from both sides. These will cancel, and we're left with the height is equal to 2.8 divided by tangent of 25.715 degrees. And that works out to be 2.8, it's 5.814 feet. So this is our height. Now we want to take this height, plug it back into the formula for our area. So again, the area is 1/2 base times height. I'm going to move this back up here. So we have the area of our triangle is 1/2. The base is 2.8 feet. The height was our 5.814 feet. And when we multiply that out, we get the area is equal to 8.1396 feet squared. So that's the area of one triangle, one of the smaller halvesy triangles, the right triangles. But there's 2 right triangles in each of these larger triangles. And then there's actually 7 full triangles in here, but each one of them is part of 2. So if we drop the height on each one, we end up with 14 of these smaller triangles. So we need to multiply this area that we calculated here by 14. So let's do that. Multiply this by 14, and we will get that the area of our heptagon, 7-sided figure there, is equal to 113. This is where I'm going to round to my 2 decimals because this is our final answer. 113.95 feet squared. That is the area of that heptagon right here. So recap, regular polygon, given just a side length, we have to calculate the central angle. Then we divide that central angle in half, use our trig ratios to calculate the height of the triangle. That way we can calculate the area of the smaller triangle, multiply it by 2 times the number of sides, and we'll get our final area for our regular polygon. If you like what you saw, please hit the subscribe button down below, and I will chat with you later.